Kia ora koutou. This is the starter for maths on Tuesday, 13th June 2023, and it's an old question from March last year's Pure 3 paper, and it's a parametric differentiation question. It's quite good practice at differentiating trig functions and at using the chain rule. So if we just read it through first, we've got two equations for a curve. So x is equal to 1 minus cos theta, and y is equal to this. And we have to show that dy by dx is equal to this. So we're going to use the chain rule, and first we're going to differentiate each function with respect to theta. So dx by d theta is going to equal sine theta, right? Because cosine differentiates to sine theta, and we've got negative cosine theta. So that's that bit done. Next up, dy by d theta is equal to negative sine theta, and then doing the chain rule on this one here, we're going to have minus 1/4 times, well, the derivative of cos of 2 theta is negative sine of 2 theta, but now I need to times by 2 because the inside function here is 2 theta. So that's what I get there. So let's clean that up. We get negative sine theta plus 1/2 sine 2 theta. Now I can already kind of see where this is going with dy by dx. So I'm going to get on with it and simplify this dy by d theta now. So I get negative sine theta plus 1/2 times 2 sine theta cos of theta, which gives me negative sine theta plus sine theta cos of theta. Now let's put that together. Dy by dx, when we're working with parametric functions, is through the chain rule dy by d theta times d theta by dx, and that's equal to dy by d theta divided by dx by d theta, and we've worked both of these two things out already. So we get for dy by d theta, we've got this, so negative sine theta plus sine theta cos theta divided by just sine theta here. Simplifying this gives me negative 1 plus cos of theta. Now let's have a look at the question and see what we were asked to show, because it definitely wasn't that. Right, well, we're asked to show that dy by dx is equal to this. So you can look at this and you can see that you've got a 1/2 of theta in there, and that's your clue to recognise that what we need to do here is to apply the double angle formula, but not to 2 theta, but to theta. And it's a show that question, so we actually need to do some steps. So there's a few of you who are probably thinking that it's really obvious. Well, you need to make it even more obvious. So we'd start out by saying this, and now we want to end up with the negative 2 sine squared. So the version of the identity that we're going to use is this one, 1 minus 2 sine squared of theta on 2. So as usual, always look at where you're trying to get to, right? And then we're done. Okay, so there you go. There's lots of little things in there just before you hit the stop button. Let's just go over all of the little bits of maths that we've had in this question. Well, the first thing is the basics on parametric. So I'll do a list over here. So in general, what's going on with parametric? Well, it's just the chain rule in a slightly different form. And this question only does the first derivative. The second derivative, we have to do the chain rule again, right? That's the first thing. We've got some trig derivatives. And we've got, what else have we got? We've got a double angle. Okay, so we've got the double angle formula popping up. And we've got one for sine of 2x. And we've got another of my double angles for cosine of 2 theta. So there's my sine of 2 theta. What else came up in here? Yeah, so being really careful with which one of the cosine 2 thetas you choose for here and looking at where you're going. I think that's about it. Some of you probably didn't particularly like that we divided through by sine theta there. I didn't really like that either. But we're not saying that that derivative is going to be defined everywhere, right? So it's okay to do that. It's just that when this is equal to 0, we're going to have problems. And what we're going to have is an undefined gradient. So the curve might be something weirdo like this, right? And when sine of theta is equal to 0 is where I'm going to have a vertical gradient of the tangent to the curve at those points. Okay, I think that's enough on that question. The next one that I'm going to do is significantly more involved, so it's going to be a longer video. Thanks for watching, and hopefully I'll see most of you guys tomorrow.